Okay, so this question says to complete the square of this function and then determine the equation of the inverse of the function. So we're going to start off simply just by completing the square, and this is a really easy skill that we learned in like grade 10, so it shouldn't be very difficult. So you're going to do x squared, and then you can't factor out anything from there because it's just a 1. So then half, I'm not going to write out this math. You know, half of 6 is just 3. 3 squared is 9. So it's going to be plus 6x plus 9 minus 9 plus 15. And this is all in brackets, that is, sorry. Plus 15. F of x is equal to, and then you're going to do negative 9 times positive 1, because that's the, I guess, the coefficient in front of the entire brackets. We just can't see it. It's just a 1. So 1 times a negative 9 is going to be x squared plus 6x plus 9, all that in brackets, minus 9 plus 15. So we're gonna we can rewrite the thing in the brackets because it's a perfect square. We can do x plus 3, and that's all squared. And then 15 minus 9 is just going to be 6, so positive 6. So we just completed the square, and we already finished the first half of this question. So the second half says to determine the equation of the inverse. So to determine the equation of the inverse, we know that we're supposed to switch all of the y's with the x's and then isolate for x. So f of x, although it is a function of x, if simply you could just rewrite it as y would be equal to x plus 3 squared plus 6, because f of x really is just y. We just don't write it as y anymore because we're in grade 11 now. So now that we're going to switch the y's and the x's, it's going to be x equals y plus 3 squared plus 6. And I think I said earlier that we're isolating for x. I meant that we're isolating for y because y equals. So now what we're going to do, we're going to isolate for y, and the first thing that we're going to do is to remove the negative 6 from both sides, because that's what makes the most sense, because it's the only thing outside of the brackets, so why not do that? So x minus 6 is equal to y plus 3 squared. So now what we're going to do, we're gonna to do what's the opposite of square rooting something, or what's the opposite of something to the exponent of 2? I kind of gave it away there. It's the square root. So you're gonna do positive and minus, because again, there's always a positive and a negative square root of something. Like the square root of 25, it's either positive 5 or negative 5, because 5 times 5 is 25. And negative 5 times negative 5 is also 25. So we don't know if it's positive or negative because there's two answers. So we're going to take the positive and negative square root of both sides. So we can now write it as the positive and negative square root of x minus 6 equals, and now it's just y plus 3 because we just did the opposite. We just canceled this out with the square root. So we got y plus 3, and now it seems pretty easy. We've got y plus 3 and then on one side, and we just want y. So we're isolating for y, so we just subtract 3 from both sides. So minus 3, and then minus 3 from this side as well. So we are now going to finish this off by writing y is equal to positive and negative square root of x minus 6, and then outside of the square root, we gotta close that off there, there's a minus 3. It's not inside of the square root. You gotta make sure that that's distinguishable, because x minus 6 minus 3, you can't just collect the like terms, because x minus 6 is all under the square root, and minus 3 is just kind of like an afterwards. After you find the square root of x minus 6, then you're going to subtract 3. So you have to make sure that the negative 3 isn't under the square root there. So now, to finally answer the question, you could write therefore, and then in function notation, you're going to write the inverse f of to the power of negative 1 of x. So the inverse function of x is equal to the positive and negative square root of x minus 6 minus 3. So now, just to put this like graphically so you can maybe understand this a bit more and so you don't just see the algebra, if we're gonna write this out, so if this right here, let me divide this off so it's a bit easier to read. So let's say that this is y equals x squared plus 6x plus 15. Obviously, you could make this really accurate, but I'm not going to go into that much detail. We just know that it's raised 6 because we completed the square. It's raised 6 and it's moved to the left by 3. So it's going to look something like this. Something like that. So then, what we know from the previous unit, or just from previous knowledge that you've already done, you know that a root function, so like y equals root x, that's gonna look something like that, right? That's what a root function looks like. So we've now got f of negative 1 of x, or sorry, the inverse function of x equals positive and negative root of x minus 6 and then minus 3. So basically, if you want to split this up, you could do one function of x. F of x is, if you were to graph this, you could do x minus 6 minus 3. Let me just close it off. And then you could do another one graphing it, but you're going to have a negative a value, so it's going to be flipped over the x-axis. So x minus 6 minus 3. So if you were to actually graph this, it would look sort of like this, because this is the positive one. It's going to go in the positive direction. If you were to flip that in the negative over the x-axis, then it would look like it would be flipped over each other. So then, as you can see, this entire thing that we just drew, we did the positive and the negative root, but that's the entire inverse function. And then, as you can see, it actually does look like the inverse. It looks like something that could be the inverse of this function because it just looks like a parabola kind of flipped over on its side. So there you can see a bit better. You can see a better graphical representation of like what you're actually doing, not just the algebra. So that is what the inverse is if you were to represent it on a graph.